This is our Global Climate Change YouTube project. My name is Carla Serra. My teammates are Angel Alvarez and Benjamin Lam. We are from Section 26. So our project is going to be focused on animal agriculture and its effects on climate change. I want to start off by mentioning that this is anthropogenic climate change. Humans have greatly impacted global climate change through the practice of animal agriculture. As population continues to increase, the demand for meat also increases. This growing demand then results in larger quantities of greenhouse gas emission, which have a direct effect on global warming. On the diagram to the right, we can see the global demand for meat. So this is a comparison of the year 2005 with an estimate of what it will be in 2050. So we can see that the demand of each category significantly increases. With this increase, ultimately what will occur is that our Earth will continue to get warmer and warmer.
From a broader perspective, the agricultural industry produces approximately 6 gigatons of carbon dioxide equivalent every year, contributing about 12% to the global greenhouse gas emissions. Methane and nitrous oxide are the two most commonly produced greenhouse gases in this sector. Carbon dioxide is also produced, but the net emissions are insignificant since the plants absorb the gas at the rate at which it is produced. Agricultural practices such as fertilizer usage for crop growing produces nitrous oxide, while livestock biological processes are largely responsible for the release of methane.
Greenhouse gases and energy costs are directly related for the following reasons. So rising livestock relies intensely on the use of our natural resources such as land and water. Much of our meat comes from large industrialized farms that currently use monocropping techniques as a source of feed for all the animals and for humans as well. This form of farming strips the earth of its nutrients and depletes water supplies while releasing large quantities of greenhouse gases. Industrialized farms are a major source of man-made greenhouse gases. On the diagram to the right, we see the energy cost of meat production. So it's a comparison. What it takes to produce 1 cup of broccoli, 1 cup of eggplant, 4 ounces of cauliflower, and 8 ounces of rice ultimately will result in 0.4 pounds of carbon dioxide, whereas a 6-ounce of beefsteak will produce 10 pounds of carbon dioxide, which is 25 times as much.
This diagram demonstrates that livestock also directly contributes to methane emissions. The manure produced by cattle generates about 1/10 of US methane emissions due to the type of stomachs these animals have, labeling them ruminants. Buffalo and cows are ruminant animals, while pork and chicken are not, therefore producing less methane. Cattle, sheep, buffalo, and some other mammals have unique stomachs with 4 separate compartments. The rumen, seen on the diagram, is the first of these compartments. Within the rumen, microbes called methogens help break down tough grasses through enteric fermentation. This process creates methane, which is released into the atmosphere once the ruminant belches.
So methane is a type of greenhouse gas that is oftentimes the result of human activity. In the first 2 decades after its release, methane is 84 times more potent than carbon dioxide. Methane is extremely dangerous because it is extremely effective at absorbing heat.
This is a short video illustrating how we as consumers can help reduce the impact of greenhouse gas emissions produced by the agricultural industry. Farmers can mitigate the impact of greenhouse gas emissions by capturing the methane that is released by livestock manure and use it to produce renewable energy. Using and storing solid manure as fertilizer rather than depositing them in anaerobic lagoons will reduce the amount of methane produced. Improving ruminant feeding practices can also help reduce the amount of enteric methane that they produce. Additionally, reducing soil tillage and improving farmland practices can reduce greenhouse gas emissions by allowing it to act as a sink that absorbs more atmospheric carbon dioxide. The picture on the right illustrates how methane can be captured and be used as a renewable source of energy. So here we have a silo that holds the manure, and the methane that is released by it gets captured by the methane bubble, which is then transferred to a generator which produces and powers the dairy barn with electricity. And that was the end of our presentation. Thank you for watching.